this keynote, the Fringe of NFV. Silvia is technical expert in concerning protesting and interoperability science. 2012. The current activities include providing testing expertise, technical management of interoperability events, and coordination of as you may know. Diego, which will also be part, senior technology expert on network internet services within the CTO unit of Telefónica MIB, and it's also currently focused on identifying and evaluating new opportunities in technologies. Additionally, I should say that for me it's an additional pleasure to have Celia here because we studied some time ago in our faculty. Yes, please.
Okay. The pointer is
this one. The pointer is this one.
Thank you. Okay, so as Eduardo was saying, I will be sharing this keynote with Diego. For me, it's a real pleasure as well to be here today. I was born a few miles away from here on the Cantabric Sea, and I started my student life a few hundred meters from here in the engineering school of Bilbao. So then I moved to France, and I'm now working for ETSI in the south of France, and it's for me a real pleasure to be back home to speak about my work. Okay, so let me tell a bit about ETSI. Many of you might already know all of this, but just in case. ETSI is the European Telecommunication Standards Institute. We develop standards. We are an independent organization, non-for-profit. It was created more than 25 years ago. Independent means that we're not part of the European Commission or whatever. We are founded by our members. And these members come from any part of the world, and with them we are setting globally applicable standards to be used in any part of the world. ETSI offers direct participation to the members. We have above 750 members right now, and quite a lot of publications that are all available for free download. You just have to go to Google it. In fact, you don't need to go anywhere. You can Google it, you can download it for free. We work with different kinds of technical bodies. The most common ones are technical committees where ETSI members meet and discuss about the technology and standardize the technology. We have also some partnership projects like 3GPP or 1M2M where ETSI works with other standard setting organizations and we develop the standards together. And we have also some industry specification groups that are now more famous, let's say, thanks to NFV, which is probably the biggest one we have. And there are also new groups for industry specification, being set for mobile edge computing, millimeter wave transmission, and many new technologies. What's interesting about this last type of groups is that it's open to ETSI members and non-members. Participation is free, just have to sign a participant agreement that gives you access to all the documentation, drafts, attending the conf calls. There are some small fees to attend the face-to-face meetings, but are really reasonable. I think it's around 100 euros a day or something like that. And okay. About CTI. CTI is the Center for Testing and Interoperability, is the division where I work. We are a handful of engineers within ETSI Secretariat. And we provide support to different technical bodies, different technologies, to help them with specification methods and tools, and also with test methodology, with the development of test specifications, with the organization of interoperability events that we name plug tests. And lately, since NFV, we are also coordinating proof of concept activities. I will speak more about proof of concepts later. About ISG and NFV, just to say that it's quite a big group. We have over 280 member companies, either participants or either ETSI members. I think the split is 40% of ETSI members and 60% of non-ETSI members. There's a good mix of network operators. We have 38 today. And then there are service providers, telco vendors, IT vendors, software companies, and research and academia as well. As I was saying, this group is open to members and non-members, and it has a global reach. We have companies coming mainly from North America and from Europe, but also from Asia and Middle East. So we are quite spread around the world. We meet face-to-face every quarter. We try to go around the globe, so once US, once Europe, once Asia. It's not always possible, but that's what we try to do. And in between these face-to-face meetings, we have conf calls, a lot of conf calls, I would say. I think every afternoon you will have 2 or 3 conf calls, depending on the working group that you're following. Okay, there are a few URLs there where you can find additional information. How the work is organized in the ISG NFV. Well, there is the NFV chair and vice chairs. There are 5 working groups dealing with evolution and ecosystem, interfaces and architecture, reliability, availability and assurance. There's a group on testing, experimentation and open source, and there's a group dealing with security aspects as well. All this is coordinated by the Technical Steering Committee, which is chaired by Diego. There is a Network Operators Council, which has an advisory role, where the operators meet and try to provide a consistent message to the group. All this is supported by the ETSI Secretariat. And I would say, in my case, as working at CTI, I'm way in the middle in between the Secretariat and the testing group. Okay, I follow very closely the work of this group. Okay, a word about the NFV specifications. I said every ETSI document is available for free download. In the case of the ISG, they wanted to go one step further, and they want to share the drafts. Even before publication, they are putting all the drafts in what we call an open area. So anyone can access and download a draft that's being developed. It's not complete, but you can already see which way it's going. This allows to set up a communication channel with other SDOs, with the industry, with academia, with research, and with open source. And what we have done as well is to put in place a feedback loop so that these external entities that are reading the drafts can provide feedback, in case they see something strange in it, or can ask questions. Okay, so this feedback loop is just a regular issue tracker, as the one you could have for any source project. Okay. The NFV proof of concept framework. This was one of the early requests from the ISG NFV. They wanted their work to be as practical as possible and as related as possible with implementations. So very early after they started, a few months after they started, they asked ETSI to put in place this proof of concept framework. They drafted what they had in mind. In this context, the proof of concept is a multi-vendor team working together to implement and demonstrate NFV concepts. Okay, so this was launched end of 2013 with the first set of NFV deliverables. Okay, at that time they were publishing the use cases, the technical requirements, the architectural framework, and the terminology. And the goal of the proof of concept framework was, as I was saying, to look for practical results, get feedback from implementers. Another important goal was to demonstrate and disseminate NFV capabilities. It has proven to be a very powerful marketing tool at the end of the day. These proof of concepts allow to explore new technology options and to facilitate gap analysis between what exists today and what's being standardized. And it's proven as well to help to guide the future NFV ISG activities. Okay, we have learned a lot from these proof of concepts. Another very important goal is to foster the ecosystem, to create a diverse and open ecosystem where there is a place for any kind of player, and by asking companies to work together, fostering cross-company collaboration. So the POC framework sets quite low barriers to submit an ISG POC. We ask the POC team to be multi-vendor, at least 2 vendors and 1 network operator. We ask the network operator to be part of the ISG NFV so that we have some kind of contact with someone in this project. The proof of concept proposal needs to be aligned with these initial end-to-end documents that were published at the same time. So it needs to either address a use case or to address some requirements, and needs to be mapped to the NFV architectural framework. So we ask the POC team to draw on top of this figure where their elements fit and who's playing which role. The POC proposal is filed according to a template to facilitate the work of the POC team. And the POC team commits to report on their lessons learned, what they have found, what they have learned with this project, to give this information back to the ISG NFV in the form of a report. Okay, the call for POCs is open during the ISG NFV lifetime. So this lifetime, every 2 years, we decide whether we continue or we stop. So we can say up to the end of 2016, it will continue for now, maybe longer. So the process is quite simple. The POC team creates the proposal, completes the template with the proposal. The proposal needs to be uploaded to the ETSI portal, and an email announcing this new proposal is sent to a specific mailing list. Okay. Then the proposal is reviewed by a review committee. If okay, if everything is clear and all the acceptance criteria are met, the proposal is accepted and the new POC is announced. If something is not completely in line with the acceptance criteria, if we are missing one of the vendors, if the mapping to the architecture is not done, or if something's missing, we get back to the POC team, who can revise the proposal and upload again. And at some point, the proposal gets accepted. Then the POC teams runs the proof of concept project. This is the hard part. They do it on their own. They provide a public demo or a webinar or something. They share the results. And at the end, they contribute the work to the working group that's dealing with the same topics as them. And they create a final report as committed in the proposal. So for this final report, there's a template as well available. Okay, to support this process, there is the POC page under the ETSI web page. So here you will have the motivations and rationale of this framework. There are some notions of what kind of support can be expected from ETSI, from the Center for Testing and Interop. There's the list of ongoing POCs. There are links to the wiki, to the POC wiki, the information about the POC zones. I will explain these concepts in the next slides. There's a wiki, which is the, let's say, the working area for these POCs. Here you can find the templates, the guidelines, an overview of the status of all the POCs that are running. Then you can also find details about the specific POCs. You will see which company is working on what. You can access the proposal, you can access the results if they have submitted them already. There's a section on questions and answers as well. The NFV POC zone. So from time to time at key industry events, we organize a POC zone. This is just an opportunity for the NFV POCs to present their results, to make their demos, show the results to the NFV community. So last year we organized the POC zone during the SDN and OpenFlow World Congress in Düsseldorf, which is a very well attended congress on SDN. There's a link to a video up there if you want to see what the POC zone was like. And there we demonstrated 12 POCs. And this year we're organizing a new edition of this POC zone, so it will happen in a couple of weeks in Düsseldorf as well. So about the POC program, how successful has it been? Well, I think now we can say it's almost 2 years after the launch of this framework. We have 38 proofs of concept either completed or either running. I was counting the other day to make the slides. We have more than 100 different organizations that have participated to one or several POCs. There are many organizations that are supporting several POCs. 100% of the key NFV use cases have been covered by these projects, and all the architectural elements are under study. And we keep receiving POC proposals, so I think we can be quite proud of this framework. So, now that we have 100% of the key use cases demonstrated and all the architectural elements under study, what can we do to leverage the framework? So earlier this year, beginning of 2015, it was agreed by the ISG to leverage the proof of concept framework and to use it to find more specific answers to more specific questions, okay? So the idea is that the different working groups in the ISG identify and document their hot topics. What are the areas where they need feedback from implementation? What are the gray areas where they are not sure how things happen? They document this and we share these hot topics with the wide community. This is put to the wiki, anyone can go and see what are these areas. And then POC teams can decide to address one or several hot topics. This is optional, this is challenge by choice. It's not mandatory for them to address any of these topics, but if it's something they are already doing or they had in mind to do, they can get better visibility by sharing their feedback on these topics. And in parallel, regular POCs, as we had before, are still welcome. The benefits for the ISG on having these hot topics documented and these POCs addressing the hot topics is that, well, it shows that it stimulates highest quality POCs. The results are simpler to follow and digest by the working groups, because there are some working groups that are very busy with their day-to-day jobs and they don't want to go through 38 reports to find the specific information they were looking for. So now, with this mechanism, they receive directly the results from the projects. They get much more focused feedback oriented to the questions the working group has asked. The benefits for the POC teams is visibility, so they are better known internally within the ISG, and they get also enhanced external visibility. They are, for example, this year for the POC zone, in a couple of weeks, we were giving priority to the POCs that were contributing to these hot topics. Okay, so what kind of hot topics do we have? I'm showing here the first hot topics that were submitted. Hot topic 1 was the use of SDN in an NFV architectural framework. I hope you will be interested about this one. This was submitted by the Ecosystem and Evolution Working Group. It's now completed. It has been addressed by 14 POC projects. We have get feedback from 14 POC projects. There's a second hot topic is test methodology from the testing working group. Third one is end-to-end fault correlation from the reliability working group. And we also have a hot topic on lawful interception. We expect more hot topics to come. So let's have a closer look about the first hot topic. How did it work? So I think we can say this was the perfect example, was the one that was created first and the one where we have got more feedback so far. We had the Ecosystem and Evolution Working Group working on a report called SDN Usage in NFV Architectural Framework. They wanted to learn how the proof of concepts that were running or that were to come were implementing and were using SDN with the NFV, within the NFV architectural framework. So they created the whole topic and they defined a template, a feedback template with very specific questions that they wanted the POCs to answer. Okay, so this was published. Well, we were not surprised because most of the POCs that we had already were dealing with SDN usage in NFV. So we got 14 POCs filling in this template and some new POCs that were submitted to address this topic. And they all sent this completed feedback template to the working group that was able to process them, maybe ask some additional questions to the POC projects. And after processing them, this allowed them to incorporate the findings into the report, and also to drive some conclusions and recommendations. And Diego will be looking at this recommendation and at this specific information that was fed back by the proof of concepts. So Diego, it's your turn. Thank you.
Thank you, Silvia. First of all, I guess that most of you know me, but just in case, apart from what Eduardo was saying before, I was working before in the academic network, in Spanish academic network in Rediris, and I precisely started working with all this that is related with SDN and NFV because, well, or I was hired by my current company because they were precisely interested in bringing the view of software a little bit more on the network, or the view of the applications a little bit more over the network, and that's basically why I have been engaged in these issues from the very beginning. When I arrived into Telefonica, SDN was starting to sound. It was something that it was beginning to happen. I'm talking about 5-6 years ago, and I remember one of the comments from my colleagues was, well, no, SDN is nice, it's a nice thing, but it's going to happen only in universities. It's an academic exercise, it's not going to have traction in the industry. Well, it has shown that it's not that's the case, and in fact, NFV somehow has been a little bit caused precisely because of the success of SDN. And that's why I was mentioning that they are deeply related. It's something that they appear, the term SDN predates NFV by probably 6 years, but they are talking about essentially the same. It's about making the network more software-based, or in the terms that I had once, I don't know if it was Hagen, Bosner, or someone else, mentioned that it's about making networking more sexy. Networking has been, the kind of stuff that was very much about graph theory, nodes, links, a few protocols maintaining the status of one of the nodes, telling about the other nodes, how it was and how the links were, about configuring the protocol, and well, inventing maybe some kind of nice distributed algorithm to apply that. But it was losing this edge of being something that was exciting, something that you could do new things with, something you could play to achieve, I don't know how to say, astonishing results, showing off what you were doing, apart from, for sure, bandwidth. It was simply bandwidth. It was, I can achieve 1 gig, 10 gigs, 100 gigs, whatever the number of gigs or teras or whatever. So these things have recently changed, according to my view at least, with the advent of SDN and NFV, and they are very, very much related. And in many cases, and it is happening right now inside certain communities, we are trying to find a term that tries to deal with SDN, NFV, and whatever that comes after, that is dealing precisely to making the network more flexible and software-based. People are talking about software networks. I don't know if that name will eventually take off, but probably would be good to start thinking precisely about a new discipline. Going back to the matter of all of this, the idea is that NFV would be very difficult to achieve if you don't have SDN, if you don't have the flexibility that you get from SDN to shape and reshape the network dynamically without direct human intervention and without applying the usual delay and principles to whatever the distributed algorithm you're applying. It would be possible, but difficult. And frankly, most of the SDN cases that you hear about outside of the data center are related to NFV. And in most cases, even those inside the data center are related to NFV. I mean, NFV understood in the general sense that you're providing the network functions by software images that you dynamically deploy in the data center or elsewhere. And this is something that, well, people have acknowledged, have started to working, and we have several results going to be produced or already produced. Well, we have this E5 report in the ISG NFV. There is an ongoing technical report on this inside the ONF Architectural Working Group. The 14 POC reports that Silvia mentioned before, and there are steps that have been taken by several open source projects. Here I'm citing Open Daylight and ONOS, but there are some others that as well are addressing this connection between SDN and NFV and making them, well, compatible or able to work in a more ambitious framework. That is not, well, this is my SDN stuff, I will focus on this, and we will consider only NFV use case, or the other way around. I'm just concerned with NFV, and I will consider only SDN as an enabling technology. But looking for a converging view that currently is part of a process of formal liaisons between the different standards bodies, discussing formally, we like this from your document, we don't like that from your document, please add this, please substitute that, and by community sharing, by starting working and making things happen. And now I have to move this, okay? Okay, this is again the list of POCs. As Silvia was mentioning before, one of the things we tried to do from the very beginning with the NFV group was to try to run away from something that has been very much criticized from the standards bodies. That is, people tend to be at a very high theoretical plane in which you're not concerned with the reality. You can bring some experience, but the experience is very soon forgotten because people is talking about, you know, concepts, things that will happen probably in the future, and they're talking about what is really intended without practical experience. We try to follow somehow this all principle about the running code and show that things could be achieved using real results coming from tests that were not necessarily 100% compliant with the standards or whatever, because they were not intended to be. We had no standards by the moment. We don't have formal standards to test against yet. But anyway, there were general architectural principles, and there were ideas that were validated and tested in the different proofs of concept. You have there the titles that can give you an idea. If you're interested, all these reports are public, as far as I can tell, or so. Well, but the only thing that you need to do for accessing them is signing an agreement that acknowledges the IPR of these documents as being from ETSI, so it should be easy to access it. They are not public, but they are very easy to access. And well, as you can see, I would say 90% of all the POCs were based on open flow, as it could be expected. So just to insist on the concepts, and this is something that, and here we start the place in which if you disagree, please stand up and we can have a discussion on whether this applies or not. It's about the concepts on when it comes to NFV, when it comes to SDN. The upper figure is from our internal presentations of what NFV is. It's about, in the case of NFV, we're talking about separating the functionality from capacity. So you have the functionality as software images, and the capacity are running on common hardware. Let me insist, we are not talking about, this is something I repeat once and again, we are not talking about completely general hardware. Very often we use this, the concept of the COTS blades that can be deployed in any data center. Not necessarily. The idea is to have a common hardware that's uniform and you can manage as a hardware in a consistent way, and that you can choose which capacity, which functionality will be running according to the requirements of the network. One of the things that have been discussed right now inside the NFV group is whether we need some characterization of the hardware. For example, for security goals. If you want to run an image on a server that is elsewhere, you very likely would like to have some assessments on the security of the environment, whether the operating system and the hypervisors are trustworthy. The other way around, if you are an infrastructure provider and somebody is going to run some image, you would like to have some assessment on how secure the image you're going to run is and whether it's going to be messing with your hypervisor or your operating system and causing some nasty results. For that, probably you will require some measurements on security implemented in hardware, because it's the only way that should be thinkable. We have been discussing recently, we were involved in a discussion, just to give you an idea how security is becoming. We are involved in 2 activities related precisely with hardware security, and now we're considering quantum cryptography for key distribution. So the idea basically is precisely increasing elasticity in all sense. It's not only about growing up, it's about moving the functions all over the place. It's about having in the ZT presentation, they were talking about elastic network, and this is precisely there. But it's not only that it's able to grow, it's about that you can move it around and you can locate the functions wherever and whenever they are needed. And reduce heterogeneity that for us network operators is a nightmare. You have to deal with an enormous pile of completely diverse and different hardware, even inside or within the scope of a single vendor. It's extremely complicated, and managing all that accounts for an extremely high cost for us. SDN, well, this figure comes from ITUT, from the definition of SDN from ITUT. It's intended not to use the definition from ONF to be a little bit more neutral, but well, there is no difference that you have application controllers and resources. And what you do is that you have, you decouple the control and the forwarding functions. You have an open protocol between the control and the forwarding, so you can freely combine control elements and freely combine forwarding elements without being concerned about who is the provider of what, and the control elements provide the programmatic interfaces. You can program the network, you can rely on a series of abstractions that are software-based. So you gain programmability, and most of all, you gain the abstraction of the infrastructure, which is, as I see it, is the highest advantage of running SDN. So mapping SDN and NFV, originally, and I can tell you because I was involved in the first discussions, the idea for the NFV proponents was, well, SDN is something that is cool. Let's use it like a programmable patch panel, something that we can use for connecting. We will have, let's say, for providing a certain function, we will have 10 machines, 10 virtual machines running different software instances, and we dynamically, when I want to a certain function to pop up in a certain point of the network, I will, onboard. It's onboard what they do. Yes. No, it's just onboard, offboard, upload, download, downstream, upstream. This is something that is, I mean, if you think about this, it's like the way in which the screws move. It's completely artificial, at least to me. So I have these 10 machines. I want to put them, let's say put them somewhere in a data center, and I want them then connected in a certain way to shape the function I want to run, which will be a different way of the five other machines that I had put there one week ago. And I need to make a dynamic interconnection among them to build the function. So how should I do it? Well, I have OpenFlow. I go and I reprogram the switches using my OpenFlow controller for this to happen. What is more, I can even have the 5 modules, and I can make the underlying network dynamic, the behavior dynamic, by using OpenFlow, and depending on the kind of traffic, having a chaining in which I have machine 1 and 3 in some cases, and 2, 4, and 5 in some other cases. So it was clearly, or it was viewed originally as an enabling technology. And I remember long discussions about this, whether SDN should be part of the rest of the picture, but the view was no. It's providing support to us, is an enabling technology the same way that hypervisors are supporting this, or the same way that virtual network mechanisms, not SDN, I mean virtualization in general, is supporting the case. Well, as part of the POCs, and this is something that comes from empirical experience, or at least close to empirical experience, not necessarily because, for sure, this has not been tested with billions of users yet, but it's going to be, or is happening right now. Empirical experience with the POCs showed that there are many other places in which having an SDN application, an SDN controller, or an SDN resource made sense. For sure, what it was supposed it does, it was that applications and controllers should live here, managing the infrastructure. That, for sure, resources could live here, or should live there, but soon people realized that in some cases it could make sense, depending on how you were combining things. You could have resources as well in the computing part, or you could have, for sure, you could have a controller as a virtual element, or a virtualized function, or why not as part of the general managing system. I assume that you all know what an OSS and BSS is, right? Anyone has a doubt about that? No. Okay. Network management. And so the idea was that there was spotted in several points on which these SDN functions could live, and that implied a much more complicated way of thinking on the relationships between SDN and NFV. It was not that there was this clear differentiation. SDN is an enabling technology, NFV is going to use it to make it happen. There are many other possible combinations. And this, now, yes. This can get even more complicated if you think about the recursion. So, SDN by definition, since SDN provides an abstraction layer, is inherently recursive. You can put several abstraction layers, one on top of the other, each one being a user, an application or a controller, or the lower one. It's true, and maybe some of you are thinking, well, yes, but this could happen only at 2 layers, maximum. Maybe this could happen at 2 or 3 layers, depending on whether you go further in applying software control principles to the physical layer. That's true. But even with 2 layers, makes things much more complicated. The number of relationships among all these squares and dots in the diagram, if you apply, you assume that there could be more than 1 layer, can become much more complicated. And this is a figure that is right now. And I'm not sure if I'm violating some copyright here. Now that I think, probably you should not record these parts. You are going to, I'm going to take my dememorizer just to make you forget about this diagram, because it comes from an ONF document, now that I realize. Anyway, so the idea is that, anyway, the point here is to show that you can have SDN controllers at several layers controlling BNFs, and other controllers being on the BNFs on their own, and that this is very important. There is two important points here about this recursion. One is the fact that there will be no NFV 0-day. NFV will have to live with physical resources and not non-NFV resources for quite a while. And precisely this kind of recursion would help to have an SDN controller that would be able to be overarching what is dealing with NFV and what is dealing with non-NFV. So you can safely go out of the NFV domain, retaining the capacity of having a software-enabled network. On the other hand, something which is important as well, and is connected with that, is how you integrate the whole NFV concept with the real attachment points in the network. In a certain moment, you can have everything completely virtual, everything completely scalable, moving around, but at a certain point, you have to attach it to a point in the network. And the most reasonable way I can think of it is precisely using an SDN controller. And it's interesting that you can do it if you are controlling the physical point with an SDN controller. You would need another one that provides you this, taking advantage of this recursion. And well, here the problem is that there are several issues that are still open and that we had to think about, like, for example, policy reconciliation when you have several layers, and the multi-tenant environments, how you separate identities there and privileges on the diagram, the multi-domain arrangements, how you establish trust in an environment that we are used to be completely monolithic. I'm the operator, I own everything, and I have my trenches, I have my fibers, I have my equipment that are connected, and I go only to a few interconnection points where rules are very clear, and I have a fiber in a patch panel that connects me to the other operator. And well, in general, how we will address having the network as a service. I mean, well, not network as a service, the network whatever as a service, network infrastructure, network functions, network services, you name it. For this is something that it comes and is one of the results I'm more interested out of this study that Sylvia was mentioning, this E5, is precisely that we have tried to identify that there is at least an intercontroller horizontal interface inside what is the NFV framework that is needed. In general, if we go back here, you will see that we have controllers in several points, but we can conclude that they are above or below the virtualization boundary, more or less. What is the point? Here? Yes, more or less around here. So the idea is to divide or consider that theoretically there is we can consider is a controller or set of controllers above the virtualization boundary, which what we call the tenant SDN controller, that is knows about the semantics of the services, knows about which are the intentions of the functions and services that are deployed on top of the infrastructure, and normally will be multi-tenant, or we will have one per each one of the tenants of services running on top of the virtualized infrastructure, and it will be more, let's say, service-oriented. And that you will have at least one infrastructure SDN controller that will be in charge precisely of the physical resources that are provided as a service up to the BNF themselves. And for sure, what we think is that this is out of scope right now. It's out of scope of the NFV group. That's why the dotted line is in red, the one connecting the infrastructure controller and the tenant controller, because they are out of scope of what the NFV group is considering. But we do believe that is something that needs to be addressed inside the NFV group or elsewhere, and this is something that is still under discussion. As an example, these are the two deployments options that we are considering. One is that precisely you have the tenant controller as part of a VNF. And the tenant controller somehow is a tenant. Don't think about it as something that is controlling necessarily OpenFlow-based switches. Probably we are talking about something that is providing a control plane for other functions, or for a function that is doing forwarding for the other virtualized functions, and what would provide could be providing, for example, service chaining mechanisms or identity-based services, or supporting on-demand provisioning of the services, taking into account a certain set of functions already available. The other one is precisely, and this is something that is very appealing to some of us, is the idea is to have the tenant controller integrated as part of the network OSS. Essentially, if we go in that direction, and I would love to see some experiments there, what we will have is that the BSS, right now, at least in the current experience, and if you know of any other style of working, please let me know, because I would be really interested in knowing about that. The BSS is something that allows you to define the formal process of the service, and is the interface you use for when the customer calls to the call center. Not that the customer is allowed to do many things with it, but it needs a human and manual translation of the business rules on operations requested by the OSS, which makes things slow, complicated, error-prone, and that brings even, you know, the typical horror stories about my phone company, whatever it is, asked me to pay 10,000 euros because of a bill that was, there was a mess with my number because it was not decommissioned on time and somebody else started to use it, things like that. So the idea is that the business, the software that is implementing the business logic runs as an SDN application. So you can make a direct connection between the business processes, the logic around how you build the service, how you bill for the service, how you make money for the service, and get the money that is needed to the most important thing in the world, that is paying my payroll. So how you make this, and you make this automatically without having to rely on asking humans in the loop. That's first are cause errors and delays, and second is something that is important, are extremely resistant to change. Whenever you want to provide a new service or whatever, it's much easier to deploy a new module that train 10 or 20 people to take care of it. Well, this is something that we have started to coin as the, well, it's BSS combined to OSS, so the BOSS view. So the idea is that move in the direction of having BOSS instead of having the separation of an OSS and a BSS. And in that respect, well, in that respect, and in the convergence and the future convergence of NFV and SDN, we think that intent is an extremely interesting path in order to have a single understanding of what a network based on software is, and how can be managed, and how can certain set of interfaces being exposed and used by the service provider and the service consumer. So intent is something that is still, I can tell you, is still very much in its initial, and there is a lot of discussions, and probably if we ask around the room, many of you will have several definitions of what intent should be, but essentially it's about, well, it's about saying, well, this separate what I want to do from how I need to do it. Let me insist on one thing. What I try, or what the idea I have, is that we need a clear model, whatever the model is. I mean, maybe we're talking about nodes and links. I'm not talking about anything else. I have 7 nodes, 10 links, they are connected, and there are some properties on the links. I cannot care less how they are implemented. Whether they are implemented layer 2, they are implemented using MPLS, they are implemented using IP routing, I don't care. What I know is that I want certain properties between 2 nodes. And that's all, which is very much connected, and this is something that I have said several times about this is the same that happened long time ago in the database industry when talking about SQL. SQL is based on a sound mathematical model that has nothing to do with records, indexes, disk access, memory, processing, or whatever. You have relations, you have tables, and you have columns, and you have data, and you have an algebra to manipulate all this. And that's all. You don't care about the implementation, and that is not caring about the implementation. That doesn't imply that you can take a great advantage of people very much aware of how they are representing data in the files, how they are optimizing queries, how they are indexing files to make things happen fast and in a reliable way. But those manipulating the database don't know about that. They saw the tables, they saw the columns, they saw the rows. Simply that. And they do operations on rows, columns, and tables. My idea of intent is going in the same direction, is having something that provides a basic model, and probably is there. Probably is applying some kind of particular graph theory and properties to this, and having a common interface for all applications, whatever we're talking about SDN controllers, whatever we're talking about the Mano stack, whatever you're talking about the network, and you are asking the network to do things for you. And that will bring, what we said there is the idea of integrated development environments, so you can apply the general principles of software development. It's having the human in the loop, but in the right part of the loop, so to say. You have the programmer. A person, because this is something that right now, when we think about this, is something that, well, for the network, the only thing I need for the network is bandwidth. I need, if I have 2 gigs of bandwidth warranty, they don't need anything else. Or you need some properties on delay, or fairness. Or you need, because of confidentiality or whatever, you need some properties on security. The point is that right now nobody's thinking about, or nobody, or very few are thinking about having those properties in the network and not properties connected to the network, which is not exactly the same. And the implications is precisely about what they say there, which is about the seek for an application network co-design. The same way that you are able to write in the same program the business logic and the data logic. You have the how to behave, how the web interface has to behave, and how you access the database. Well, there, in intent, at least, there are several ongoing activities. In ETSI, we have proposed an activity precisely on intent and NFV in the ITF and in several other places. Well, as a joint conclusion, this is you can, well, Silvia, you can come here and we can make a duetto. Just to so well we are no come here, because then people will start to throw things at you. No, simply just to insist on the fact that inside the ISG NFV, or the NFV ISG, how is it? ISG NFV, okay. Inside the ISG NFV, we have tried to follow a path that is not only about this formal process around standards creation that is back from the far from the reality and far even from the reasonable theoretical foundations. We had tried to make it practical and to demonstrate and to explore the coming challenges we will find, and we expect to transform what is the proof of concepts that will continue as part of the hot topics, transform them in plug tests that, if you're curious, Silvia can tell you what they are.
So the plug test is interoperability events that we organize for the technical bodies. So we hope very soon, or at least not within much time, we'll be ready to have some kind of plug test for NFV. This requires some kinds of standardization. This requires some kinds of abstract concepts as well, to make sure that we can write test descriptions that apply to any kind of implementation. But it's very practical as well, because at the end of the day, we bring the implementations, we put the implementations in a room, we put the engineers in a room, and we ask them to run these abstract tests and make things work.
And they blame one another.
Yeah. So hopefully we'll be seeing this in a near future.
Okay, just to conclude, the best demonstration of this practical approach has been precisely that we very soon identified that the connection between SDN and NFV had to be addressed in a different way, just as not only considering SDN as an enabling technology. Well, we are working on several definition and implementation initiatives, and we hope to have them demonstrated anytime soon. Well, for those of you who are interested, and most of you are researchers, I do believe that intent-based interfaces are the next frontier we have for convergence. And that's all, right?